The explosive birth. How the universe forged its first building blocks. 13.8 billion years ago, the entire universe was nothing but energy, an unimaginable sea of pure heat and chaos. But how did that chaos turn into the matter that makes up everything, stars, planets, and us? What happened in those first millionths of a second? And how did physics turn energy into the particles that built reality? Today on Fresh Science Daily, we uncover the explosive birth of the universe's very first building blocks. What was the universe like right after the Big Bang? In the very first split second after the Big Bang, the universe was so hot that ordinary matter couldn't exist. Instead, space was filled with an extreme soup called the quark-gluon plasma, a fluid of pure quarks and gluons, the tiny particles that later form protons and neutrons. Temperatures reached over 1 trillion degrees Celsius, hotter than the core of any star today. In this state, the laws of physics as we know them were stretched to their limits. How did quarks become building blocks? As the universe expanded, it also cooled, and for the first time, quarks and gluons lost enough energy to stick together. Tiny fractions of a second later, they combined into stable clusters, protons and neutrons. This transformation from pure energy to matter is what makes our entire physical universe possible. Without it, there would be no atoms, no molecules, no stars. This moment, known as hadronization, was one of the universe's most dramatic phase changes. Why didn't all matter disappear instantly? One of the biggest puzzles in physics is why this new matter survived at all. In theory, every particle should have had an antiparticle twin, and when particles and antiparticles meet, they annihilate each other, turning back into pure energy. So why is there matter left? Physicists think a tiny imbalance, maybe one extra particle for every billion, tipped the scales. That tiny leftover is everything we see today: galaxies, stars, planets, and life. How do we study this now? Scientists can't travel back to the Big Bang, but they can recreate a taste of that ancient chaos in modern particle accelerators. At the Large Hadron Collider at CERN, physicists smash heavy ions together at near light speed, producing a miniature quark-gluon plasma for just an instant. This lets us study how quarks interact and how the universe's first matter might have formed. It's like peeking back in time, using machines built on Earth to unlock secrets from the beginning of everything.
Why does it matter today?
Understanding how matter came to be helps us answer the biggest questions. Where did we come from? What is everything made of? And could there be unknown forces or particles we haven't found yet? Every time we recreate this tiny moment of the universe's explosive birth, we get closer to understanding how reality holds together, and whether the same laws of physics apply everywhere, from our backyard to the edge of the cosmos. In the blink of an eye after the Big Bang, the universe turned energy into the tiny building blocks that built us all. It was chaotic, it was extreme, and it left behind the atoms that became stars, planets, and life. What secrets still hide in those first fractions of a second? And what new physics might we uncover when we look deeper? Tell us what you think, and stay with Fresh Science Daily for more big questions about the smallest pieces of our universe.